Hello friends, in previous lecture we have studied the application of congruence relation. We will continue application of congruence to find the remainder of some number is divided by some other number. So we will take the example, find the remainder when 41 raised to 65 is divided by 13. Find the remainder when 41 raised to 65 is divided by 13. Solution. So here first we will divide 41 by 13. So here 41 is congruent to, if I divide 41 by 13, 41 threes are, if I divide 41 by 13, what is the remainder? 13 threes are 39. Okay. 41 minus that means 2 modulo 13, as 13 divides 41 minus 2 is equal to 39. So we get this. Is it clear? Then if I take its square, then I am getting 4 here. Is it right? If I take 3 power, then we will get 8, 4 power 36, 4 power 36. Okay. So what we will do here, we will divide by 2 raised to 65 is again big number. So we will find a number in such way that 2 raised to 5, 2 raised to some number is congruent to some 1 or minus 1. 1 or minus 1. Now 2 raised to 6 is equal to 64 is congruent to minus 1 mod 13, as 13 divides 64 minus 1 is equal to 65. Right. So 2 raised to 6, which is nothing but 64, is congruent to minus 1 mod 13. Is it clear? Therefore 41 raised to 6 is congruent to 2 raised to 6 modulo 13 moreover this is 1, this is 2, right, this is by 1, and A is congruent to B mod n implies A raised to k is congruent to B raised to k mod n. By using this we are getting this one. So 41 raised to 6 is congruent to this from 2 and 3 now. A is congruent to B mod n, B is congruent to C mod n. Okay, we will get, therefore 41 raised to 6 is congruent to minus 1 mod 13 from 2, 3 and transitivity. 41 raised to 6 is congruent to 2 raised to 6 mod 13, but 2 raised to 6 is congruent to minus 1 mod 13. Therefore, 41 raised to 6 is congruent to minus 1 mod 13. Is it clear? Now, we will divide that 65 by 6. Okay. Now, 65, if I divide by 6, what will get? Or if I take its square also, okay. Therefore, 41 raised to 6 its square is congruent to minus 1 square mod 13, and therefore 41 raised to 12 is congruent to 1 mod 13. 4. Now, we'll divide that 65 by 12. Now, 65 is equal to 12 into 5 plus 5. Right. From 4, which is 60 plus 5. From 4, 41 raised to 12 raised to 5 is congruent to 1 raised to 5 mod 13, and therefore 41 raised to 60 is congruent to 1 mod 13. Right? Now, what to find out? 41 raised to 5 is congruent to how much? 41 raised to 5 is congruent to how much? So, 41 is congruent to, now 41 is congruent to 2 mod 13, 41 square is congruent to 2 square is equal to 4 mod 13, 41 raised to square is equal to 4 square is congruent is equal to 4 square, 16 mod 13, but and 16 is congruent to 3 mod 13. Therefore, 41 raised to 4 is congruent to 3 mod 13. Therefore, 41 raised to 4 into 41 is congruent to 2 into 3 mod 13. Mod 13. Is it clear? Therefore, 41 raised to 5 is congruent to, this is 1, 2 into 3, 6 mod 13. This is your 6. From 5 and 6, 41 raised to 60 into 41 raised to 5 is congruent to 1 into 6 mod 13. Therefore, 41 raised to 65 is congruent to 6 mod 13. So here we are using the properties A is congruent to B mod n, C is congruent to D mod n, then AC is congruent to BD mod n. We are using that properties. Okay. Now 41 raised to 65 and 6 leaves same remainder when divided by 13, and 6 is the remainder when 6 is divided by 13. Therefore 6 is the remainder when 41 raised to 65 is divided by 13. Is it clear? So this is a very good application of congruences. That 41 raised to 65 is too big number, it is difficult to find that number, but even though we are able to find its remainder when divided by 13. Okay. So we will take one more example. Prove that 111 raised to 333 plus 333 11 is divisible by 7. Means if we divide this sum, then the remainder must be 0. So solution. So firstly, we find the remainder of 111 raised to 333 divided by 7. Now here 111, if I divide by 7, okay, what will be is nothing but 7 into 1, 4, plus 6. Is it right? So 6 is the remainder. So therefore 111 is congruent to 6 mod 7, as 7 divides 111 minus 6 is equal to 105. Right. So this is 1. If I take its square, now, what will get? Six square. Okay. Now 111 square is congruent to 6 square is equal to 36, and 36 is congruent to 1 mod 7. Seven divides 36 minus 1 is equal to 35, which implies 111 square is congruent to 1 mod 7. Okay, this is 1. So if I divide 111 square by 7, remainder is 1. Now we will divide this 33 by 2. Okay. Now 333 is equal to 2 into 1, 6, 6, okay. Plus 1. Is it clear? If I divide 333 by 2, remainder is 1. 2 ones, remainder is 1, 13, 2 6 are 12, remainder is 1, 2 6 are 12, remainder is 1. Okay. So, from 111 square raised to 166 is congruent to 101 raised to 166 is equal to 1 mod 7. Is it clear? And this 111. This is 1, this is 2, this from 2, this is 3, from 1 and 3, from 1 and 3, 111 raised to 2 into 166 into 111 is congruent to 1 into 6 mod 7, and therefore 111 raised to 2 into 166 plus 1 is congruent to, okay, this is my say star. What will this? Is congruent to 6 mod 7. So 111 raised to 333 leaves the remainder 6 mod 7. A. Now we will do same thing for 313 raised to 111. Now Now 333 is congruent to, if I divide this by 7, this by 7, what is the remainder? Okay. So is equal to 7 into okay. So 333 is congruent to 4 mod 7, since 7 divides 333 minus 4, which is nothing but right. 1 minute. 7 4s 28, 53, 7 sevens are 49, 7 sevens are 49, right. So 7 fours are 4. Yes, now it is correct, right. So 333 is congruent to 4 mod 7. 4 mod 7. Is it clear? What this implies is, now we'll find the remainder. We'll apply, I want remainder to be 1. If I take 4 square, that is 16. Okay. Four is to 3, 64. Is congruent to 4 square is equal to 16. If I divide by 7, is congruent to 2 mod 7, right. 2 mod 7. If I take its power now, so it leaves the remainder 2. 16 divided by 7 gives us remainder 2. Okay. If I take now its power 2 cube, okay, 302 raised to 3 is equal to 2 cube is equal to 8 is congruent to 1 mod 7, right. 1 mod 7. So raised to 6 is congruent to 1 mod 7. This is your 4. Now we'll divide 111 by 6. Now 111 is equal to 6 into 1, 5, right. Yes, 111 is congruent to this. Therefore, 300 from 4, 6 to the power 18 is congruent to 1 raised to 18 is equal to 1 mod 7, 5. Right. Now what to find out? Raised to 3 here. Raised to 3. Okay. 300 cube is equal to 302 into 333 is congruent to 4 into this square is congruent to 2 into 4, right. That cube, yes, cube is congruent to this square 4 square is congruent to mod 7, right, and this is 4 into 2, that is 8 is congruent to 1 mod 7. and therefore 300 3 is congruent to 1 mod 7, right. From 5 6 100 300 6 to the power 18 into 333 raised to 3 is congruent to, this is 1, this is also 1, 1 into 1 mod 7, and this is the star 2. So 333 raised to 111 is congruent to 1 mod 7, right. This is B. From star 2. From A and B 111 raised to 333 plus 333 raised to 111 is congruent to 6 plus 1 is equal to 7 is congruent to 0 mod 7. 0 mod 7. Therefore, this implies leave the remainder 0 when divided by 7, when divided by 7, and therefore 7 divides 111 raised to 333 plus 333 raised to 111. Okay. So these are the good applications of congruence relations for finding the remainder when big numbers are divided by given numbers. Otherwise, it is difficult to solve such examples. Very good applications of congruence relations. So with this discussion, we will stop our session here. Thanks for listening lecture carefully. If you haven't subscribed channel, please subscribe channel. Bye bye.